ADB, Asian Development Bank process. So it started in 2020, and since then we are adding up several activities under this TA while working with the agriculture department. So one of them is the digitalization of agriculture departments, and the important aspect is that we are working with the four crop reporting services department and ministry and building their capacity on remote sensing. So the objective that comes under remote sensing is the crop area estimation, crop yield estimation, crop health monitoring, and then flood mapping. As for a country, it is important to have a timely and accurate crop area and production results so they can make some timely decisions on trade and national food security, which is the mandate of crop reporting services. And they do the transit walk to estimate the crop area, and then they have, for particularly in Punjab, as they work on the area frame sampling, they work on the crop cut method to estimate the yield. So this is where the remote sensing chip in, and not to supplement the methodology of crop reporting services, but to complement it, so they can use it for the validation purposes of their crop area estimates, the yield estimates, even the cultivated area of the vegetation. But there are some prerequisites to it, which is, I would like to say, which are the challenges, like the limited capacity of crop reporting services, except Punjab, of course, because they are ahead, and they have a GIS unit, and no GIS lab. And recently, KPE has developed their GIS lab. So we are building their capacity in terms of all the core aspects, core objectives, and we deployed a couple of our resources in crop reporting services so they can follow up and they can keep building their capacity. So to introduce remote sensing, we collaborated with ICRISAT, which is an international organization, and we together building the capacity of CRS department. The goal is to keep the solution sustainable. So we are focusing on those satellite images which are sustainable in terms of which are freely available. You do not have to put chip in money. So that is Sentinel-2, which is 10 by 10 resolution, and then we are using MODIS, which is 250 by 250 resolution. But of course, for different purposes. Ground truthing is a word which we use for having a field survey, and for that we build an application. What exactly ground truthing is, to get to the ground and get the real information which is there in the field. So we capture several information regarding those area, which particularly is the irrigation method, the crop type, the coordinates, and also take the picture. We build an application where we have a high resolution imagery in it, so we can clearly identify the acre where we drop out the coordinate. So we can have an accurate information while we head towards the crop area estimation analysis. So that is just an example that we performed a ground truthing on a massive scale. I believe this is the first time in Pakistan who have gathered on such a massive scale the ground truthing points. In Rabi season, we collected more than 40,000, and 40,000 points represent the 40,000 fields. And in Kharif, we gathered 90,000 points with the help of 11 teams. And the green points that you can visualize on the screen is basically the spread. These are the points that have been taken on ground. So let's talk about the area estimation method. What we do, we are basically using two platforms. One is Google Earth Engine that we call a cloud platform that uses the Google server for the computation of satellite images. And then we use the desktop versions to label our classes. So what exactly we do, we compute 70 or 80% of our work has been done on Cloud Engine. We fetch Sentinel-2 imagery, we compute the NDVI, we get the maximum value composite. We do the analysis in the time series. We take the complete period of a cropping season. We gather the satellite images for that time period. We compute the NDVI, we get the maximum value composite. and we stack all the information together. This is where the ground truthing point are utilized. We overlay those ground truthing points on top of the stacked imagery to get the spectral signatures. Spectral signatures are the phonology of a crop, to understand how they behave in terms of remote sensing. And then we prepare the ideal spectral signatures, which is the ideal behavior of each crop, that when it has been sown mean of each cluster. We combine one set of information, that is the true phonology of crop, with the cluster information. We merge them up, we take the correlation, and then we label and we get the result. And then we ultimately, when we have a result, we overlay the unseen data on top of it, so we can see the accuracy of our results. So this is how the classified image looks like. The land use land cover has been classified as a wheat and rice cropping season, wheat, rice and other. We can merge. If we just need to identify the rice area, then we have to merge first and second class together. Okay, so second intervention is the crop stress monitoring. We have been working on crop stress monitoring before even 2022, but when the flood came, we worked with the PDNA to identify the flood extent, so we can conclude how much crop has been damaged. But we took a step ahead and we started monitoring the crops, those who are under the flood, so to identify if they are reviving their health or not. So crop stress monitoring is done to achieve or to see the health of a crop. And in our result, as you have seen in this previous image, there are three colors. The green represents no stress, red represents the severe stress, whereas orange color represents the moderate stress. In this part of crop stress, we use the MODIS imagery. And what exactly we do is we take the time frame of our analysis. Let's say the flood came in the end of August. So we take those 15 days, we get the imagery, and we compare it with the historical data of last 4 or 5 years, and we consider them as the normal condition of a crop. And then we compare that normal condition of a crop with the current condition, and to conclude that if the current condition is according to the normal condition or it is behaving abnormal. And then later we identify the abnormality, that what could be the reason for that stress. So this is the time series data, how it looks like in terms of map from June, July, August, and September. And after the successful implementation of this study, we started to develop a bulletin for the crop reporting services and ministry to share the monthly report on crop status during the cropping season. Success story is that the ministry has the foundation level of understanding of remote sensing. The other crop reporting services have started estimating the crop area, and the good part is the KP and Balochistan has started producing their own estimates by their own staff. And lastly, we have collaborated with Crop Reporting Services Punjab. This study is in progress to identify the correlation of NDVI with the actual yield, because they are using the area frame sampling, they have the actual yield, and they have the coordinates of it. So we are trying to see the correlation, if we can predict the yield with a good correlation, and we can look into the opportunities of the crop insurance on much granularity. Thank you.
Any questions from the audience? Please react.
Thank you very much, Noman. It was a wonderful presentation. And again, I must say that Asian Development Bank is doing a very tremendous, job in strengthening and capacity buildings of the agriculture department overall. So